All right, guys, we just got done talking about logarithms, how to convert them, what they do in the first video. The second video, part 1 of 9.3, talked about evaluating. Okay, now we're in it in a bigger way. We need to go deeper into evaluating because clearly there's more to than just converting it, because that thinking part can get more difficult. Okay, so we need to talk about these more complex examples. All right, so here we go again. Rush Mahaber, Wayne State University. I haven't said this to you guys in a while. I don't know who else is listening at this point, so I figure we might as well let them know where we're all from. All right, so and let's just recall from the last part of evaluating, okay? And literally how we got through the whole last 5 examples was just converting them, right? We turned the base into the base, right? The answer, which was what we were looking for, was an empty box, and then the answer, which was 100, then we converted it into the answer's place in exponential form. Well, 10 to the what power gave us 100, and we just started playing with it. And you can just start counting up until you get to 100, right? And then there's some cases where it was not like that, right? We had to use bigger exponents and exponential properties and our laws of exponents in a different kind of way. So 25 to the what power, right, which was 1/2 at that point, equals 5. So we set that thing up and we had to start thinking about it. The only thing that can shrink down a base is in fractional exponent, right? It's because we're taking roots at that point. So we had to start thinking about that. And then likewise, like the example before, we know if we had 1/overs in answers, our answers could be a negative exponent, right? So all the things from chapter 1.6, okay? But it all came down to converting it. So when we left off is right here, where both of these things, right? Now, by the way, those things, they're actually not called the answer. Their actual name is called the argument, all right? But the reason why we say answer is because when we convert into exponential form, they're in the answer position, right? Where the answer would normally be written at. So, right, 5 was the base of 5. The answer or the argument is 1. And then the answer or the exponent here, right, in exponential form is what we're chasing down. So that thing we figured out was to be 0, right? But then we said, okay, what about pi, log base pi of 1? Okay, well then that means that log base pi of 1 has to be 0 because pi to the 0 power equals 1. Done, right? Now, well, let's check out a few more of those that are like that, okay? Because I think we're on to something here, and this is going to start our talk of exponential laws and actually evaluating exponentials, okay? So here we go. So I want to give you this guy early. So log base 10 of 1, okay? What is that guy? Well, that guy is going to be 0 as well. Well, why? Okay, so you can always check or justify your answer. 10 to the 0 power is 1. Is that true? Absolutely, okay? So now that we know how to think about it, we can now start throwing numbers in there and using that thought process of how we thought about it instead to just check ourselves. Okay, kind of like guess and check was for factoring. It's kind of the same thing, right? We were doing a checkoff to make sure we are actually thinking about this the right way. But if we don't know where to start, we'll convert it and we'll think about it. Okay, so but we're getting more and more experience. All right, so how about this one? Oh, by the way, and what if you just had log of 1? What does that mean? There's no base there. Well, good news, if they just do log of 1, then that means that the base is 10. Okay, the base is 10, they just didn't write it there. Okay, so you're still to think about it the exact same way, and that'll run us back into the exact same explanation as before. So I'm not going to waste video time talking about that one. All right, so bottom line is, what are we seeing here? It doesn't matter what the base is. Okay, I don't care what the base is. So in general, okay, this is all I know, is that log of any base, we'll say A, of 1, right, is always going to be 0. Why? Well, because convert it. A to the 0 power is 1. Does that look familiar to you guys? Wasn't that one of the properties for our laws of exponents? So every one of those properties that we had in the laws of exponents are now going to have a whole bunch of logarithmic kind of size, right? So I'm going to start showing you guys comparisons. So this was the property that we had in section 1.6. This is its log conversion. Okay, so bottom line is that every one of those properties are going to have possibly a log conversion. It may be useful or may not be useful, right? So that's always the question. So if anything, we might have a little less, but every one of them have a conversion. We're going to talk about it, okay? So, but anyhow, we'll get into that in the next section probably. Right now, I really just want to focus on doing logs in a much more aggressive kind of way. All right, so here we go. Here's evaluating. All right, so this one came from the final exam, okay? And I'm probably going to go about 2 or 3 examples. from previous finals. Okay, it says log base 12 of 1 over 144. Okay, so what's this guy? Well, here we go. If no one knows the answer yet, okay, you can start playing with it in your head, playing with it in your head, playing with it in your head. But bottom line is, if you can't figure it out, then you got to go and you got to convert it. You say 12 to what exponent is going to give me 1 over 144. And this is my thought process, okay? If it's a 1 over, I'm pretty sure the exponent has got to be negative. Okay, so I'm going to put a little negative there because that's going to flip it upside down. Now, if this is the case, then how is my base of 12 going to turn into a 144? Well, my guess is going to be is that I square it. Now, let's check it out. So here's my check. 12 to the negative 2 is 1 over 12 squared, which is 1 over 144. Check it out. Life is good. Okay, so therefore the answer here has to be negative 2. Okay, so convert it and then play with the numbers. And as you play with it more and more, you'll get faster and faster and faster. First time will take you a couple minutes. Next time it'll take you maybe 1 minute and then 30 seconds. And pretty soon you'll just be flying through them like most people do. Okay, but you got to start somewhere. That's the point. All right, let's run through another one. Okay, we'll probably have, in this video, I'll probably do 3 or 4 more because they go by pretty quick. Okay, let's make it a little more complicated. This one came from 2009. I know these are older, but I think those were harder finals. Okay, let's see if you guys can think about this one. So this one's cute, okay? The base is 1/8. Yuck, right? The answer is 1/2. The argument's 1/2, and then the answer, I don't know if you guys know what to do here. So I'm going to rewrite it as 1/8 to what exponent is equal to 1/2. All right, so you got to start thinking about whether or not you could recognize patterns here, okay? So I know a lot of you guys are seeing, oh, well, they're both already 1 over. Well, yeah, that's what they have the same. So what do they have differently, okay? Well, check this out. I know 1/2 and 1/8, they have relationships, right? So think about it. If I have 2 to the third power is 8, right? So 1/2 times 1/2 times 1/2 has to be 1/8. So basically there are 3 2's inside that 8, right? So what do you think that exponent has to be? I don't know. It's not going to be negative because then I'll flip it right back, right side up. So I don't want it to be negative, but I think I have to shrink that 8 down to 2. So my thought process is let me take a cube root, or what I like to call the 1/3 power. Okay, so let's check it out here. I could be wrong. So this is the cube root of 8, right? So this is the check. So I'm checking out what's right there. And this ends up giving me, well, that's the cube root of 1 over the cube root of 8, which gives me 1/2. Bingo, bongo, bongo. You guys are right so far? So sometimes it can get a little tricky, but it's no more than what we already have, okay? You just got to stop and think about it, all right? And now here's maybe a little better connecting point before we just move on. That 8, it's important that we leverage that we knew 8 and 2 had a relationship, right? If 8 and 2 don't have a relationship, then it's not going to be easy to do. Like if that was a 7, then we have a problem. There's nowhere to go from here, okay? So let's be very conscious of the fact that we had to know that, it took us to multiply 3 2's together in order to get 8. And that's how I knew I needed to take a cube root to shrink that 8 that's in that denominator down to a 2, okay? So that's why we know that the answer is 1/3. Done and done. All right, let's look at another one. Okay, so they're getting a little more complicated, but it's no big deal. All right, so let's look at this guy. How about this is a good one. How about I think that's a good one. This one came from fall 04, and this is log base 1/10 of 100. Okay, so this one was particularly interesting because even thinking about it was hard. So I'm going to make the answer unknown. We're going to convert it over. 1/10 to what exponent is 100. All right, so now you're going to have to play some games here. Okay, I already see that the only way 10s and 100s can be the same is if I square them. Okay, but it's 1 over. I want to turn it right side back up, right? So what I'm thinking is, and here's my guess, is that this is going to be a negative to flip it upside down. And then I'm going to square it, and by squaring it, it will turn it into 100. Okay, so, but again, we're never just going to throw it in there and go for it. We are always going to check our work. So here's my check. So 1/10 to the negative 2. Well, negative -2 would definitely mean this is an entire thing like so. So either you actually get that this means 1 over, keep the same base, and then square it, right? Then you run through it, which is 1 over 100. Keep, change, flip, or multiply by the reciprocal for all you fancy people out there, which gives me 100. Bingo bongo. Okay, so at the end of the day, it still gives me the right answer, okay? And if it doesn't give me the right answer, then I know that I screwed up somewhere in the exponent. But here's the thing. Let's say that was really stinking close, and then let's say whatever I need to do, maybe I just need to put a negative on it, right? Maybe it left it in a 1 over 100 kind of state. And then I was like, oh, well, I just need to put a negative on the exponent. So the work you did, even for your wrong work, will help you get to the right answer. Okay, so never think that your wrong work is there. No, it's your first attempt. It's still going to lead you in the right path, or you can use part of it. It's never going to be all wrong. You guys know enough by now. Okay, so it's 100. So bingo, that's -2. Okay, easy. Okay, so it's all about noticing the patterns. All right, last but not least, I think that's a good amount of examples, guys, and we're running already a little long. So, next video, we'll get into section 9.4, which are the laws of logarithms. All right, well, we got to be good at evaluating them because they are not all done in terms of solving them. They can always get more and more difficult, but we got to know how to think about them. That's the most important thing. All right, guys, see you on the next video.